All right, let's start with number 7. There was a request for that. Number 7 is a lot of writing in the question, and basically all they're saying is, in order to solve this problem right here, which proportion is correct? Can I go 8 over 14 equals 30 over 12? I'm sorry, x over 14 equals 30 over 12. Or do I have to go x plus 14 over 30? Did I write that down wrong? What in the world? Which one's right?
X plus 14.
X plus 14, yeah, how come?
Because it's like something to do with the base. It's like the base.
Yeah, still too much chat. Yeah, this is one of those situations where since this is an entire side of a triangle, I have to compare that to entire sides of triangles, and unfortunately x, that segment right there, is not a complete side of the triangle, so I can't use it in that kind of proportion. So it's a little bit confusing, but you can go like, if this over here was 6 and this was 12 or something, then you can go 14 and x and 6 and 12, and that'll work out. But that's because this is a fraction of the whole triangle side, and this is a fraction of the whole triangle side. So those are basically the same kind of creatures, so you can match them up. Okay? But as soon as you bring in a base of the triangle, like Richard said here, or the 30 that they use there, then you have to use the entire side of the triangle. So it turns out that this is the right one. The whole side of the big triangle divided by the whole side of the little triangle equals the whole side of the big triangle divided by the whole side of the big triangle equals little side, little side. Okay? It's a little bit confusing, I know, to understand when it's okay to use the pieces and when you have to use the same thing. Does anybody have a good way of explaining when each one works?
Has the base in there.
Right, anytime it has a base of one of the two triangles in there, you have to use the whole side. Does that make sense a little bit?
I'm listening to you.
That's not what you should be doing.
Well, what else am I supposed to be doing
You're
now?
supposed to be listening to me and like looking at your homework,
Well, I was gone on Friday.
which is even more reason.
Well, if
But
you're
always-
recording it, then why? What?
Erica for paying such great attention. Okay, number 10. So number 10 is only just a little bit tricky because things are divided up into multiple pieces, but the idea is the same. Do I need to use the entire side of this triangle, or can I just look at the pieces? The pieces are okay this time, yeah, because unless, Richard called this the base, even though it's rotated a different way, but unless you're using one of these big whole flat sides like that, you can just use the individual pieces within the proportion. So will somebody please raise their hand and tell me what proportion you could use to solve for x? Hannah? 22 over 12. Okay, so you're going to be difficult. That's fine. 22 over 12 equals?
18 plus x over x.
All right, 18 plus x over x. So that will work, okay? Because what she did is she went this whole thing right here, which is 22, divided by this little thing right there is going to equal this whole thing right here, which is 18 plus x divided by that piece right there. Okay, and it's good practice because these come up. When I cross multiply these two, what do I get? 22x, because if I cross multiply this way, 22 times x is 22x. And then 12 times 18 is 180 plus 36, 216.
Sure.
Yeah?
plus 216.
Okay, plus another 12x. So then I subtract 12x from both sides. Ooh, did I do the math wrong there? Oh, no, it comes out 3 decimals. Good. Okay, so 10x equals 216. So x equals 21.6, which is the correct answer. Can somebody raise their hand and tell me an easier proportion that you could use? Yes.
12 over x.
12 over x equals 10 over 18. Yeah, and that will also work because if you cross multiply this way, you get 216 like before, and that way you get 10x, so you get the same answer.
I did 10
Okay.
over 12.
10 over 12 equals 18 over x. Yep, that'll work too. Okay, so there's quite a few different ways that you can set up these proportions. And you'll get the right answer every time. Okay, so now we know that x is 21.6. Now we need a proportion to get double, yeah. Anybody want to try that one?
Can I do it?
I don't know, can you? Go ahead. Try.
24 over
24 over what?
18.
Okay, 24 over 18
And W over 10.
and W over 10. Okay, so he went with this side and that, or that piece and that piece goes with this piece and this piece. So as long as you match up corresponding parts of the triangle, you're going to be okay. So if I cross multiply this way, I get 240. If I cross multiply this way, I get 18W. And then if you divide both sides by 18, W equals what?
13.3 repeating.
13.3 repeating. So it turns out the answer is yes, Richard, you can.
I can do it.
Yes, you can. All right, where are we going now? 13.
She's the only one. Okay, Jesus tree with this was scary. So you give me the dirt one, take mine. It's yes, yes, yes.
Okay, 13. What do we want to do for that? Anybody have any good ideas for 13? When I look at the answers, this looks like a tricky one.
Line parallels the y-axis, and then do it to the vertex within the right triangle, and then you find out the hypotenuse.
Okay, take a line parallel to the y-axis. So like speaking French there. Okay, so here's my line parallel to the y-axis, and where do you want me to move it?
Wait, never mind.
Oh, I'm sorry, you're right, that's not parallel to the y-axis. What was I thinking? That is parallel to the x-axis. Okay. All right, so where do you want a right triangle? Right here?
Yeah.
Okay. So, but do we know any of the sides of that right triangle?
The bottom side is 9,
How come you know that?
because the whole side is 12, and then the vertex is over 3.
Oh, did it say the point for the vertex also, and I just didn't write it down? No? Yep, okay, gotcha. So we're missing some information, that would help. So this is 3, 9, okay? Good deal. So that, all right, so now I'm with you. So now you know that this side right here is 3, this piece right here is 9, and so you said since this is a right triangle, you're going to go Pythagorean theorem on us?
What is the other side?
What do you mean? Oh, this side over here? Okay, so if this is 3, then this whole piece must be 9 from there to there. Okay, oh, and then this is 9, right? So that tells you that this whole piece right here has to be, it's a 45, 45, 90, yeah, so that means that this whole length right there, which would be A plus B, is equal to 9 root 2. That's what you came up with? Okay, and then where do we go from there? Okay?
But if you go that side and then motion the other side.
Okay, gotcha. So now that you know that this whole entire side is 9 root 2, then what you're saying, I think, stop me if I'm wrong. Erase some stuff here to unclutter our diagram. So she just took and drew this line right here to get a right triangle. And it happens to be a 45, 45, 90 because the height of this right here has to be 9 because the y-coordinate of that is 9, right? And since the x-coordinate of that point is 3, that means this bar is 3, which leaves 9 from there. So this whole side is 9 root 2. And then now you totally like forgot about that whole right triangle thing, is that what you're saying? And just went with proportions. Okay, so that means, whoa, that means, let me get this point right here was what again? 8, 0? Okay, so give me a proportion that you use then to solve for A or B. Because this little piece right here is 8, right? And this whole thing is 12. So you can go, very nice, 8 over 12 equals B over 9 root 2. Do you guys see how she got that? Once she knew what the whole length of this triangle was right here, then she can just say this little piece here, which is 8, divided by the entire length, which is 12, is going to equal this little piece right here, which is B, divided by the whole length, which is 9 root 2. So the reason we couldn't do that before is because we didn't know what the whole length was. We just knew that it was A plus B. So we had to sneak in there with that Pythagorean theorem in order to figure that out. All right? Very nice. So now when you cross multiply, you get 72 root 2, and then 72 divided by 12 is 6. So B equals 6 root 2. It is like calculus, huh? And then if the whole thing has to add up to 9 root 2, then that means A has to be 3 root 2. Very good. No, I don't think so. I think that's, I could have explained it a little bit easier because I didn't quite understand from the beginning what she was getting at. So I think I made it sound a little bit more complicated than it actually is. But no, in order to do that, we need to know what the length of this entire side is right here. Okay, so that's the only way we can come up with that. All right, nice job. Where am I going now? 22. 22? You need number 25? Okay, I think kind of the consensus was once we got to 22, then we're just going to run the table here.
Yeah.
Okay. So we'll get there in a second. So here's 22. And it's a word problem, and everybody loves those. Okay, so 22. We are trying to figure out, because we're real estate agents, how much riverfront property each one of these lots has. Now my suggestion to you, if you're a real estate agent and you're in this situation, go to the county courthouse and look up the records for these lots, and it'll say right there what it is. Okay. Or you could just go out there and measure it. Yeah. Or you could be a good real estate agent and just lie. And just understand that nobody's ever going to actually go out there and measure it and then call you on it, as long as you're close. But in geometry class, I guess we need to set up a proportion. So, who's got it? Mackenzie, you certainly have this one, I'm sure.
36 over 96 x over 120.
Okay, so she goes 36 over 96. Now, obviously, the 36 comes from right here. Can someone whose name is not Mackenzie tell me where the 96 came from? Yeah. All three of them added up together. So one of the first things she did, just like on the last one, we had to know that whole missing side of that triangle in order to set up a proportion. So just like in that, she added those up and found out the whole entire side on the road was 96. So this little piece over the whole piece equals x, this little piece right there, over the whole piece, 120. And then you cross multiply and divide. I'll leave that to you. So now that you've seen this, can somebody else give me a way that we can figure out what y is? Just anybody at all. Okay, good. Now we can do the same thing, but if we're going to figure out y, we're going to go 32 over 96, because 32 is what matches up with the y, equals y over 120, and then solve that. It should be easy now. How do we figure out what z is? 28 over 96 equals z over 120, or what'd you say? Somebody say? Somebody said subtract? Yeah, okay. What were you saying about subtracting? Right. Once you figure out what x and y is, another way that you could do it is just subtract those two answers from the 120, and what's left over will be z. Okay? So I will let you solve those simple stroke portions on your own. Okay, number 23. Okay, it says the ratio of the surface, ready? Keyword? Areas. Of two cubes is 49 over 81. We want to know what's the ratio of the two volumes. Okay? So if you know the ratio of the areas, what can you do to those two numbers to get the ratio of the sides? Yeah, square root it. So square root of 49 is 7. Square root of 81 is 9, and that gives you the ratio of the sides. We want the ratio of the volumes, so then you have to cube those, right? So the ratio of the volumes would be 7 over 9 cubed, which is 243 over 729. 3 what? Oh, 343, thank you. 343 over 729 would be the ratio of the volumes. So if you start with the areas, you got to square root it to get the sides, and then you want volumes, and volume is cubic, so you have to cube the two numbers. Okay, 24. Romunda. Romunda's original recipe for her spherical cannonball cookies. Make 36 spheres with 4 centimeter diameters. So when you have 36 of the cookies, then the diameter of each one is 4 centimeters. Okay? She reasons that she can make 36 cannonballs with 8 centimeter diameters by doubling the amount of dough. So she says, well, if I want to make the cannonball cookies be twice as big, since I'm just doubling this dimension, then I just need to double the amount of dough. Is she right? No, of course not. Her name's Romunda. What does she have to do to the amount of dough she has? What? 4 times by 4, yes, because she's doubling the diameter. And so if you want to figure out how that's going to affect the, oh no, not 4, sorry, you said 4. The cookie dough is what kind of, what aspect of the cookies? The volume, right. So we don't need to square this, we need to cube it, right? So you need 8 times the dough. If you wanted to know like how much more frosting you needed to put around the outside, since that relates to the surface area, then you would need 4 times as much, because 2 squared is 4. So she's going to need a lot more dough. All right, and finally, 25. Find the surface area of a cube with edge x, then 2x, then 3x. Okay, so let's get ourselves a cube up here. So if this side is x, and this side is x, and this side is x because it's a cube, what is the area of one of the sides? X squared, right, because you just go base times height. So this is x squared. What's the area of this one? X squared. Of this one? This one. This one. That one. Okay, how many are there altogether? 6. So the total is going to be 6x squared. Okay? If you double the length of the sides of the cube now and make each one 2x, what they're trying to get you to understand, or just hammer home the same idea, since I doubled the dimensions, does that mean that the area is going to be doubled as well and give me 12x squared? No, because what would the area of one of the faces be now? 4x squared. And how many faces are there? 6. And so 6 times 4 is 24. That means the total surface area would be 24x squared. So we doubled the dimensions and we got 4 times the area. And now we are going to triple the original dimensions and make them all 3x. Okay? Does that mean we get 3 times the original area? No. What times the original area do we get? 9 times, because 3 squared is 9, so 6 times 9 is 72x squared, which we could have figured out directly if we said this side is 3x, that's 3x, so the surface area of that side is a total of 9x squared, and then like before, there's 6 of them. 6 times 9 is 72, so the whole thing is 72x squared. Okay, what? Oh, did I do that wrong? Oh yeah, 6 times 9 is 54, I said 72. Okay, it's Monday. Thank you. It is? It's all the students' excuses too, so we're even. All right, will you pass those forward, please?
John Doe.